Okay, good afternoon. My name is Mark Morana. I'm a senior consultant within Financial Professional Services, Division McAfee. The scope of my talk is to introduce a business case for building security in the software lifecycle. And this business case is based upon common knowledge of security development lifecycle and our experience with clients and some data from public data available from case studies. So the outline of presentation I will talk about in the glossary. I will just cover some common terminology that I'm going to talk during the presentation. I will put some emphasis between application security and software security with a different perspective. I will mention some data you can use for making your business case based upon the cost of application security versus software security, and the metrics you can use to talk to the executives, which is the return of security investment, for which you can make the business case and the cost-benefit analysis. I will introduce to you different ways to implement the software development life cycles based upon process models quite available right now, or how to build your own framework based upon our consulting experience with clients. We'll put some emphasis on integrating a business impact and technical impact in order to lay down the risk remediation strategy. And then in the summary, I will give you some lessons that for you to take away. Information security risk from the perspective of information risk management is the probability that a particular threat source will exercise a vulnerability, resulting in an impact, and impact can be both business and technical impact. This is based upon a NIST publication on the information risk guideline that you can actually look yourself on the NIST website. A very good definition of most of us in the industry know the difference between software security and application security, but somehow it's misused, especially in some commercial applications. The best definition I found out is from Exploiting Software, a book from Gary McGraw, which is an academic leader in the field. And so software security is a way to defend against software exploits by building secure software, whereas application security, you kind of like tackle the risk when the application is already deployed. A return on security investment is the definition we take here is from Microsoft Security Risk Management Guide, which is the total amount of money the organization is expected to save in 1 year by implementing security control. And this metric is used to decide the cost benefit of implementing security control during the risk management. So let's talk about risk, where they are, and if you look at the evidence, if you like evidence, I was actually watching on TV a CSI investigator. This CSI investigator saying, "Oh, I don't believe what you're trying to tell me. I just believe the evidence." So the evidence is that 92% of vulnerability right now reported are in applications, not on networks. So if your client is very network-centric, using the network-centric approach, is primarily concerned about deploying firewalls, deploying IDSs, and spyware, this is a good case you can make. And this 92% includes server and non-server application and operating systems vulnerabilities. How we approach risk from the standpoint of application security versus software security. When in software security, we approach risk from managing risk throughout the software development lifecycle. So we look at the problem from the perspective of the root causes of the problem. In application security, we look from the tactical point of view. We just look for a fixed-up solution. We look at the issue. Very typical example, buffer overflow. I can tackle buffer overflow from the standpoint of software security and look at the input validation issues. Or I can just apply the patch. This is the application risk, the application security approach. So think about it, because whatever you're talking about application security, you're kind of like limiting your scope. And this is shown in this diagram here. Really, software security is thinking about all the big components that are part of the process, technology and people. So which are the costs? These are public data you can take are quite available. You can make the case from the standpoint of application security is very expensive. Think about, on the average, you will get between 5 and 15 defects for 1,000 line of code. You can factor how many hours, many hours it will take to research the problem, to find the solution, and develop the solution. And so, and extrapolate, you know, for 150 hours per defect, and you come out with these numbers. Patch management, these are the costs that impact the total cost of ownership. These are the costs that impact the vendor, not the vendor, but your client actually using your software. So 1,000 server, deploy the patches for 1,000 server, test the patches before being deployed. These are the costs, and these are data from Gartner, quite reliable indeed. Or you can think about the impact of losing productivity because of a degradation of a service, of a completely loss of a service. And so this is the data based upon the black year 2001, when for a few days the Microsoft servers were attacked by named and code red. So from the perspective, so you can make a strong case based upon these data. From the perspective of software security, when you're not tackling the risks from the beginning, you end up finding defects at the end when it's too late. And so what happens, you're going to allocate man hours from other projects just to try to get the project released. Again, data from Microsoft, how much the IT department was tracking down resources to be allocated in different departments in order to fix the security problems. And 1,000 man hours being allocated just to get the releases done. If you have your data already, if you're already tracking, you have a metric and measurements within your organization, of course, you can use those data, but this is just to make you, to point out which data are important to look for. Of course, there is no such a thing like free lunch, so if you're going to implement security in your software lifecycle, you're going to spend money on training. So $100 million were spent on 2001 by Microsoft for implementing the Trustworthy Security Lifecycle Initiative. And of course, you can have big numbers you can apply to, like the cost of inadequate software testing costs. That counts in the billions. When do we address the problem from the software security perspective? This is an old study made by Capers-Jones in '96, but it's still valid today. If you look at the percentage of bugs that have been introduced during the software life cycle, which is the light blue line, 85% of the defects are normally introduced during coding. But when we do something about it, when we actually found the defects, it's just late in the software life cycle. If you look at the yellow line, it will tell you clearly that we found most of the defects during the testing phase. How this is impacting the cost? This is impacting the cost from coding to unit tests to function tests exponentially. So what that means is that when we spend only $25 to address the problem when it happened, to fix the security defect during coding will cost me 4 times during unit tests, 10 times or 400 or 640 times during the operation. So with this diagram, you want to say, I want to stay on the left of the ground. I want to tackle my security defects as early as possible in the software life cycle. And this metric is okay when you're talking to project managers that they need to allocate resources. But when you need to have customer buy-in, your executive buy-in, from the standpoint of implementing security, what you are going to talk about? The question you will be asked is, when is more effective? I have different options. Which one is the more cost-effective to implement to? You cannot go to an executive and say, oh, we need to invest $100,000 in security, otherwise we'll be hacked. An executive will ask you, I want options. I want a cost-benefit analysis. So you can use the data. This is a major study being provided actually by Kevin Su, a stake using data from IBM and other vendors. In this data, the return of security investment is shown that the return of security investment in terms of dollar saving is much higher when the defects are fixed and identified during design. So what that means is, if I engage security engineering activities during design, like architectural risk analysis or threat modeling, I have much more benefit than to wait later during the testing. Software development life cycle is really managing software risk throughout the life cycle of the development of the software. And this is really the nice picture that we would like to achieve. Out of many security activities, we have one secure process. And you build this based upon foundation. It's not just the process itself, it's also people and tools. You have a matrix that's already implemented, fine. Leverage that matrix for example, software quality assurance. Integrate this with a security matrix as well. How do we get there from a perspective of our customer experience is by adopting an activity-driven approach. And this activity-driven approach, the activities are derived by best practices. Best practices are security requirement engineering, are secure coding reviews during the coding, are secure testing. So based upon a customer experience, define clearly in your guideline what these activities are. Also define for each activity dependencies and prerequisites. For example, if I need to do threat modeling, I may need to do before use and misuse cases, or which artifacts are needed for each activity. For example, for threat modeling, I may need architectural design diagrams to do my analysis. Define entry scenarios for each activity means like event triggers. You can use action diagrams to do that, to define what I have to do if I am engaged in the software development of, for example, defining the requirements. I can trigger an activity of evaluating secure requirements. Very importantly, this point 5 is the one most important, I think. Define both a strategic and a tactical plan for those activities. A tactical plan is a plan that you can implement in a short time, like in 1 week, for example. You can do like a whiteboard exercise and understand the application, and then issue some remediation strategy based upon initial assessments, like, for example, penetration testing or a code review or a threat modeling. You can get the benefit in a short time. These are, from our client perspective, these are band-aid activities. But also think what you can do strategically as a next step. Define roadmaps for the activity. Like you may have a software is already developed as your legacy software, and the application is already in production, or the application has to be in production. So define roadmaps for the two alternatives. Position the activity. If your company is adopting different methodologies for software development, position these activities for those methodologies. So if you develop software with Agile or XP or Waterfall or RAP, identify how you can build in software and these methodologies as well. The important thing is that your methodology has to be agnostic, is independent from which kind of software development methodologies you are implementing. What it provides you from the standpoint of common knowledge, what common knowledge provides you are security enhancing lifecycle process models. They are basically based upon assessment, verification, and measurement.